let's take a look at another example. During the early years of the Olympics, the height of the winning pole vault increased by approximately 8 inches every 4 years. The height started at 130 inches in 1900. If h gives the height of the winning pole vault, then h is a function of time t measured in years. And so now I have a few things I'd like to do. Now what I know is h is a function of t. So my inputs are years and my outputs are heights. Part A. What is the average rate of change? And again, remember average rate of change? Interchangeable with the word slope. You might be able just to look at this and figure it out right away, or it might be more helpful for some of you if you make a table. So what we know is in 1900, the height was 130 inches. So there's my time, there's my height. And then I'm told it increased by 8 inches every 4 years. So if I go 4 years later to 1904, it would be 138 inches. So now I could compute the slope by doing change in y, but I don't have y's this time, I have h's, over change in x, but this time that's a t. So if I subtract my heights, that gives me 8. And if I subtract my years, that gives me 4. So that gives me 2. And the units would be inches per year. So on average, the height of a winning pole vault increases 2 inches per year. But of course, what we know is it's really 8 inches every 4 years since the Olympics are held once every 4 years. But part B. Make a table showing the winning height every 4 years over a 16-year period with t equals 0 corresponding to 1900. So I'm going to have times and heights, and they tell me 0 is 1900, and I know that was 130 inches, and I need to go by 4s every 4 years, so 4, 8, 12, and 16, and I increase by about 8 each time, so 138, 146, 154, 162. And again, times in years, height is in inches. So suppose I'd like to graph this. Well, here's my time 0, 4, 8, 12, and 16. Those are my times. My heights, and I'm going to start at the 130. So I know I'm going up by 8, so I'm going to cheat a little bit. So there's 138, 146, 154, 162. And so what I have is 0, 130, 4, 138, 8, 146, 12, 154, and 16, 162. Now, because the Olympics are held once every 4 years, I might be inclined to not connect the dots. And in this case, I'm not going to. But notice if I had, we would actually see this lovely linear function that we have. Well, suppose I wanted to find the formula for that linear function. What do? Well, early on, particularly in section 1.3, what your book does is it makes use of the old y equals mx plus b. We've already computed the slope. We know the slope is 2. And b remembers the y-intercept, and remember, the y-intercept is the point 0, comma b, and so notice if I look at my data, I have the point 0, comma 130. So the b is 130. So I then would have y equals 2x plus 130. And then if I use the right letters of the alphabet, I'd have h is 2t plus 130. And there's the answer.